Hello friends, in today's class we are going to talk about special classical interprocess synchronization problem, and in that category we are discussing bounded buffer problem. Welcome here, and we are talking about this bounded buffer problem. And let me just recall in previous lectures when we talk about inconsistency, I told you that in previous lectures that what is a bounded buffer problem. Okay, so all things started with there only, that what is basically a bounded buffer problems. So this is the bounded buffer problem, and we have uh, this producer produces the information that is consumed by consumer process, and there is unbounded buffer places no practical limit on the size of the buffer, and bounded buffer assume that there is a fixed size of the buffer. So right now here this case is count is 0, producer has not produced any item, and in that case consumer has to wait. If the buffer is empty, okay, the buffer, so we will take a variable empty over here, and here in this case count is a shared variable. So count become 2, count become 3, count become 4, count become 5, count become 6, 7, 8, 9, 10. Now producer has to wait for the consumer to consume the item. So after that producer has to wait, right? So buffer is full, then producer will be affected. I need a full as a mutex value, and that will control the producer. And if buffer is empty, then consumer has will get affected. Initial buffer full will be initialized to the value 1, and empty will be initialized binary semaphore to the value 0. And I need another variable that will take care of this count, because that will get into the inconsistency, lack of synchronization. Okay, so that was the whole idea of this algorithm, and here we have seen all everything in that context only. So okay, so now this is problem solving. Okay, now here, so we assume that pool is consist of n buffers, bounded buffer problem, and n buffers, and each capable of holding one data item. Mutex the Semaphore provide mutual exclusion for accessing the buffer pool initialized to value 1. So mutex mutual exclusion, that is one mutually exclusion, and that will initialize to the value 1. Empty and full are the semaphore. The semaphore count the number of empty and the full buffers. Okay, number of empty and full is a semaphore count. Semaphore empty is initialized to the value n, and semaphore full is initialized to the value 0. So we are using a 2 or 3 semaphore. Mutex is for that mutual exclusion 0 or 1, and empty and full here in this case is your counting semaphore. I said it for empty, I said it to be 0, but empty will be equal to, sorry for that, empty, how many empty, counting for counting semaphore, empty is n, and full is what? Full is equal to 0. So wait empty, okay, wait empty, the producer code, okay, if it is empty, so if empty is right now n, the wait will be very successfully execute, and it will make it n minus 1. Wait mutex, mutual exclusion, okay, if it is 1, then definitely it will go to this, next code. So then it will add the next item to the buffer, then it will signal the mutex, okay, and here when we are putting the item into the buffer, we are just we are preserving the mutual exclusion in this case, and then we'll signal full, increment it. If you look at the consumer code, then here in this case is wait if it is full, okay, consumer, okay, so consumer will see that if it is if full is equal to 0, full is 0, and in that case if it executes this this statement, then it is stuck here, okay. And similarly, if the producer is keep on producing item and empty becomes 0, and in that case if you want to execute the item, then it will stuck here, okay, understand here. So producer will stuck if empty is equal to 0, the number of items, the cells is equal to 0, then that producer will stuck. And initially nothing is full, full is 0. So that will make sure that consumer is stuck. Wait mutex, signal mutex. And after that, once it will consume an item, then it has already consumed one and it will make the empty cell count increasing. Okay, so if you look at both of this code, a very clean code here. Okay, I hope you understand that how this empty and full is working. I'm able to make you explain this small synchronization, classical synchronization problem, which is allow the producer to wait when empty is 0. So there is no empty location, and that case it will stuck here. Mutual exclusion, only one process will be there, so that is about your count updation. And here, if wait is 0, if full is 0, okay, full is equal to 0, okay, then consumer, okay, if the number of items, okay, the number of items are if it is no nothing here, in this case full is 3, full is 4 in that case, so it has to wait here, it will stuck here. Okay, so initially consumer will go and it will see the full value is 0, so it will stuck here, come back here. Or the count to the number of empty and the full buffers. Okay, empty and full buffers respect. The semaphore empty is initialized to the value n and all n location empty. Semaphore full is initialized to 0, 0 buffer is full. Okay, so that way we can achieve the mutual exclusion. Okay, so that is your producer and consumer problem. And we are using summarizing in this way, that here we have a mutex, mutual exclusion initialized to 1, full. So initially how many full? Nothing will be full, so 0. Initially how many empty? So n will be empty, in that case it will be n. Okay, so that is example of classical producer consumer problem and solution by using semaphore. So that's all for this discussion. Thank you.